Hello everyone and welcome to Handmade Hero, show we code a complete game live on stream. We split up the PNG reader yesterday into two parts because we have to integrate it into the game now. We built it in a test app first that just takes in a single PNG and writes out a BMP so we could verify that we were reading it correctly, and we seem to have debugged it at least to the extent that we need to read the files that we actually care about, which are the ones that come from the art department for our game. So at this point, really what we need to do is figure out where the memory is going to come from, integrate that in, and capture the debug output. We sort of started doing that at the end of last stream. We didn't get very far because we ran out of time. So that's what we're doing today. This is some very straightforward architecture work. Should not be super complicated, but it needs to get done. So if we bring up our test PNG program here, that's this. This is still the code that's necessary to run the PNG to BMP converter that we basically were using as a test case. We now have pulled out the PNG part so that the PNG part is isolated and we can start building into something else. The something else building part of it, however, is going to require us to actually tell it where to get memory from. So really at this point, if you look, we have already isolated the debug output part so that all of the debug output and information or error reporting, any of that stuff, now goes to a stub function that just throws it away, but in the future we can save it. So that's good. The other thing that we need to do here is we need to make it so that the memory allocation comes from a known place. So we had already made sure that malloc, as you can see, is isolated. It's only called right here in these three places where we know exactly what we're allocating and why. We have stream chunks, pixels, and the Huffman table because we don't know how big the Huffman table has to be, for example. So these allocations in question are things that we want to change into coming from a particular memory arena. And we want to provide that arena to the system so that what can happen is, as the game is running, when it needs to load a PNG, it can tell the PNG loader where to get the memory from, so it's not just grabbing memory willy-nilly and in some way that is uncontrolled. So what we want to do is we want to start breaking this up into things that are going to use specific memory arena, possibly more than one, because we may want to have one understanding of where the memory arena, like one memory arena for temporary operations and one memory arena for where we're actually going to permanently store the data. But in addition to that, we have to understand the fact that because this is actually just temporary art loading code, probably what's actually going to happen is all of this is going to be considered temporary. So my assumption of how I probably want to structure this code is we're just going to use a single temporary arena. We're going to allocate everything into the temporary arena. We're going to hand that back to the caller. The caller is probably going to do some pulling out, because remember, these are like basically sprite sheets at this point that the artist can give us, a sprite sheet. So all of these cells in a given file then want to be pulled out and put, for example, into permanent store and into the texture system, whatever. Then it all gets thrown away. We don't need that sprite sheet anymore, right? The sprite sheet is not relevant to us after that point. So I think what we want to do here is just recognize the fact that probably we don't need to think about memory management at all in this system. I think this system just gets an arena, it does all of its work inside the arena, then returns, and the caller will just clean up that whole set of things because none of it will be relevant once the caller is done processing the output image. So that's what I want to do at the moment. We can see we have handmade memory here, this memory arena and so on. So you can see I've explained how programming works here in a nice comment. It's only 3 lines long. Tells you everything you need to know about programming. Resource acquisition is initialization is bad. 0 is initialization is good. So you've got, there you go. That's all you need. You can stop watching Handmade here now because you've learned it all. So what I want to do now is I want to go in and make sure that all of these systems, the allocate pixels, allocate chunk, and allocate Huffman, all of these want to be able to work with an arena instead of with malloc. To do this, I would like to include the memory system we already have, because obviously I don't see any need to start creating another one. I want them to be integrated. So I'm going to see if I can just integrate Handmade Memory, but don't know that I actually can. Yeah, so you can kind of see that one of the problems that we're going to have here is that, for example, the platform memory stuff it's sort of dependent on that. I don't know to what extent that will cause us a problem. Looks like we need our maximum macro here, and I'm not sure whether or not that's something we can just, replicate here. That's in Handmade shared. I could just make that also be included. Again, we don't care what's included in the test app. So in test PNG here, I could just say, hey, let's bring in that shared bit as well. And then I can compile and we'll see what happens. No such file, is it not? It's right there. Oh, haha. Got a little transposition there. So, did we already include it or something? Struct redefinition. That's the same. Did I already include that somewhere? Color me confused. Is it like included some? Oh, so we actually include that inside Handmade shared. So I guess if we just include Handmade shared, we get all of that. Probably for reasons I would rather not think about. Anyway, so if I have the memory subsystem now, what I should be able to do here is I should be able to pass the memory that I want into the Handmade PNG reader, and then the same thing can happen in the game and in the test app. The test app will just create an arena for it to use, and it'll use that arena. So if I just pass in a memory arena here, then this, which is just a size malloc, this just becomes a push size that's going to take, the same a number of bytes here and produce the blank sort of block for the pixels. No big mystery about what's going on there. The chunk allocator here really should be over with the stream stuff. I think we want that to be over in Handmade Stream, actually. So I'm going to move that over there at the moment. I want to look to see where we're calling allocate chunk, because, yeah, I think it's getting called actually. Yeah, it is in here. So what we want to do now that the stream is sort of more of a first-class citizen, this operation of adding a chunk to a stream, this will no longer be the only place where that actually happens. So what we probably want to do is make that a little bit more systemic. So in here, I think what we want to do is pull this data out and say, all right, this piece of code, I shouldn't say data, I should say code, this piece of code here that appends a chunk, allocate chunk can now sort of be rolled into one thing that looks more like this. And what we could say is, for a particular stream, the allocation can happen, and then the pushing on of the content size and that sort of stuff can be something that happens based on what the parameters of the function are. So, append chunk might be our new thing. We take which stream to append the chunk to, and then we take how big you want it to be and what the content should be, right? And what we could do here as well is say, look, do you want this allocated, or do you want this to be, do you want me to allocate the size or not? We could have stuff like that in there as well. What I probably would say is, since it's arena-based now, we don't really have to care. So probably what we could say is just, hey, if you wanted some of the memory to be allocated for storing the contents, you can just do that as well using the arena. It doesn't really matter. So when we append a chunk, what we really need to tell it is what the size was and what the contents are. And I think this is actually technically U8, but we don't really care. So when we allocate this here, what I'd say is we'll just pass the size, we pass the contents, and then everything else just kind of takes care of itself. This is the stream here. And so instead of comp data, which was the old variable name for it, where from the code we pulled it out of, we're just going to go ahead and put this in like so. So that appends the chunk to the stream. And now what we want to do is we want to have this be some kind of an arena push that we do here. Now we want our stream to understand where to get its memory from, I think. So we probably want that to be part of the stream as well. So the stream knows where it's going to get the stuff that it's actually pulling from. So, you know, I don't think we need to pass that in here. I think we want to just say that what we're doing here is we're doing a push struct on the stream, the memory that was specified for the stream, and we want a stream chunk from that arena, and it's just going to allocate one there, like, you know, increase the space and you know, push it back. And I think that's it, right? Now, at some point we probably want, you know, this stuff here, we probably want to push stuff onto a free store. So when we advance, so when we do refill as necessary, I want to put a little thing that's here, you know, that says something like, to do Casey, you know, use a free list to recycle chunks if we ever care. We don't really know what we're going to do with the stream stuff. It's kind of just a very simple little struct that we're using for some, you know, simple streaming purposes. It's just kind of underbaked right now, but I'm going to leave it underbaked because I don't need to start engineering this thing. It may never matter to the behavior of our program. We may never need it to do more. If we do need it to do more, then at the point where we need it to do more, that's the time to actually go through and make it, you know, conscientious about what it's doing and all the other sorts of things we might want. This is not the time to play around with that, I don't think. All right, so this is Append Chunk. It'll append a chunk to the stream that you give it with that size. So inside the test code now, when that actually happened, I'm sorry, inside the Handmade PNG code when that actually happens, we're really just doing an append chunk here where we pass in the information we got, like so, and we just want the comp data struct to be the thing where that happens, right? So the comp data now is something that, you know, again, all initialized to 0 will just work, but you need to then start placing some certain pieces of information in there if you want it to be able to do things like allocate its own chunk memory. So what I would like to do is have just a little like how should I put, well, you know what? Honestly, I think this is all we really need here. So on-demand memory stream can just take an arena and it can take an error stream. And if you just set the error stream to 0, then it just won't record any errors, right? So I'll actually just say that's what we're going to use. So you can say I want an on-demand memory stream, and you'll get one. Again, all this is going to do is just say, all right, we'll 0 everything, because remember 0 is initialization. And then we just set the fields that we actually cared about, which are these two. This one may not be set. In fact, even this one might not be set if you didn't ever plan to allocate anything on it, but, you know, presumably you do. So we can just call this an on-demand memory stream now, and we pass in the memory arena that we actually want to use, which is something that should come from the outside, so it'll get passed in here probably. And then we also have where we want the errors to go, and I think we just want that to be whatever the file's error stream, whatever the other stream's sort of error system was, that's what we're going to use. So that's where we're at. I think we're pretty good so far in terms of how that's going to work. Again, I don't think there's any mallocs in here other than these two that we were looking at before. So I think that getting rid of this one, oops, should do it. So here we have another thing that's going to allocate basically an array. We can, you know, this was kind of unsafe. Again, I don't like malloc because it doesn't have the structure that we want to ensure that we don't make simple preventable mistakes. So if I do a push array here, that's much better. I can say, oh, this is how many of those I wanted, right? And this is what I wanted. So it allows me to make a simpler sort of more understandable, more reliable way of expressing that same thing that will cast to the right thing on the way out too. So if this, if I put the wrong type here, it will error instead of working, which like the other line would have done. So that's what we want to convert to something that requires arenas. And now we're going to have to make sure that those things are passed through. For chunks, I don't know what I want to do in terms of sizing. Right now, we're kind of riding out the 32-bit sizing. I don't know if that's a good idea or not. Maybe it's not. I'm not sure. Anyway, I'm going to have some of this stuff here take memory again as it was before. So like we said, an arena gets passed to everybody and they all work out of that arena, and that arena will probably get discarded on the way. That arena is going to come in at the head end, like so. So now I think about it, yeah, we could actually pass the errors as well in there. I don't know. Or we could get it from the file stream. I'm not sure how we want to do that. There's a lot of ways we could. It doesn't really matter. But anyway, I'm going to do it like this. There we go. So now all that stuff is coming from the system correctly. We want here to create one of these memory arenas. And the only thing is we don't really know how to create it yet because we're in a test app, not in the actual game. So we have to cross that bridge in a second here. But just other than that, it's pretty straightforward. We're just going to do something like this. Now, we don't have the ability to specify an error stream basically until we have one. So this one's not going to have an error stream, but we could have the info stream have an error stream, because once we have an error stream, we can use it. So everybody else can use the error stream. That's fine. Once we do that, I think we're good to go. Now we just need some way of getting the memory in here. And so what we want to look at the memory system and see what's the easiest way we could emulate the platform layer effectively in order to make this thing work. And so if you look at how this is working, normally when we create one of these memory arenas, we have to do some kind of initialization to it that allows it to get memory. You can see in here, for example, when you allocate memory, it can try to call to get a new block, right? So you see this platform allocate memory stuff happening there. So since we don't have a platform subsystem outside in here, what we'd have to do is sort of emulate one, which really isn't a big deal, right? Because the only thing that platform subsystem needs to do is provide memory to this, so we can make it think that it's sort of running on the game without too much trouble, right? Should be fairly straightforward. So if I just initialize this memory system to 0, then what we'll see is everything actually works fine, but because we're now calling that allocation call off of the platform global variable, the linker is thrown into a panic because it doesn't know where it could possibly receive such a thing, right? It's like, I don't have that global variable, so how am I supposed to call a function off of it, right? Which is a very reasonable thing for a linker to say. The linker is an eminently reasonable sort of a person, I feel, and it is right to complain. So where is the struct platform API stuff in here? Oh, it's right there. So you can see what we're looking at here, and you can see there's a number of things that deal. It's a fairly minimalist platform layer, which is great. But what you can also see is that it has the two things that we actually care about, allocating and decallocating memory. So what we could do, again, is just say, all right, we'll put one of those in here, platform API platform. Now it's been defined. And really all we need to do is make sure that the one or two functions we may call, which would be allocate and deallocate memory, make sure those actually exist. And so if we go into the platform layer and we look at what's happening, you can see it's got a lot of stuff in here that we made, We don't care about any of this stuff. This is not like, we don't need any of this, right? All we need is the basic operation of allocating the memory. So I'm going to call this CRT allocate memory. And oops, there it is. Deallocate memory, right? So I'm going to call those the CRT versions. And now we can just thunk through to malloc and free just like we were doing before. So all I'm going to do here is say, okay, if we got a block passed, we just free the block. That's it. When we do allocating memory, we need to return a platform memory block. That's what has to happen here. Platform memory block, I think, is kind of a semi-opaque thing. It's got a little bit of information on it. But you can see what happens here. When we come in here, we do a size plus the size of the memory block header. Then we do a bunch of stuff, and we allocate the size plus however big the memory block header is, right? So I don't know if... I assume the platform memory block, yeah, has a size. You can see it here. So what we want to do here is just say, all right, there's a platform memory block. That's what we need to allocate here. And then we need also the size, the amount of memory that they actually asked for. And you can see here that that's the size parameter that's coming in, through this macro here. So what we want to do is we want to take the size of the platform memory block. We want to add our size, and that's the thing that we actually want to malloc. So when you get memory, you get one of those, and that's it, right? My understanding is this has to be cleared as well. So what we want to do is take the memory block, that whole piece of memory, and we want to clear the whole thing. So I might do a total size thing here, like so. Allocate the total size, clear it out. And then if there's anything in here that we need to set, we can set it. I don't know that there's anything particularly relevant to set, but you can see it in here. So, you know, if we look, there's this stuff. So I would say just, yeah, set the size. We know it, right? We want to set the base because I think that's the thing that's actually going to get... that's the thing that's actually going to be used as the pointer, right? Yeah. So we just want to offset ourselves from that. So we take the block and we add 1 to it to move past it, and then that's our... well, I guess that's it, right? Oops. So CU8. And I think that's really it. I guess I should have put D in front of that. And I think that will allocate memory for us in exactly the same way that the game does in terms of what the memory arena wants. But instead of calling virtual-alloc and virtual free, we're just calling the CRT version. So this remains a CRT program for our test program, which is what we wanted. Right? So now Handmade PNG is nice and swifty because it's not relying on anything that's in the C runtime library anymore. It's completely platform separated, and now it can exist inside the game or outside the game, and it's happy to do either, which is what we wanted. So that's good. Now, what I want to do as a next step is I want to make sure, A, that still works, and B, I want to get the error streams working so that we can still see the output of it. So again, it compiles just fine. We don't know that it works. I could have introduced a bug. I could have implemented the memory callbacks wrong. Plenty of stuff like that. So let's just see if we get any nonsense happening. We don't quite yet. So we didn't do anything obviously wrong, so that's fine. But we're not quite done yet. Like I said, inside the stream thing, you can see here we have this OutofCall. The OutofCall is something that's designed to provide printf functionality to people who don't actually want to call printf because there may not be a printf, such as in the game. So what we want to do is get that functionality back. Well, we already implemented, I don't remember where, to be completely honest with you, but we already implemented a printf. I'm not sure, okay, well, it's right here, so I guess correctly. We have this thing called FormatStringList, and you can see that gets will do all the work for us that we actually cared about. So if I wanted to, I could create an equivalent function to what we've been using in the game for doing a printf, just like this. I can grab the arg list, I can go ahead and call format string, and then I know that I've got effectively like a buffer filled with the data that I wanted. So what I can do here is I can use a temporary buffer. I can say like, okay, I don't know how big it has to be, but we can just have a 1K buffer on the stack. We'll quickly fill that with something. And then when it's done, we know how big it is, so I can then push that thing onto the stack. Now, I don't know if that includes the null terminator or not. To be completely honest with you, it looks like it does not. So this is the amount of size that is not including the null terminator. Did we mention that anywhere? So in our case, we do want to, don't want to. I mean, we don't need it because we're storing these things in chunks. I don't know. Yeah, I mean, I got nothing. So, we want to append a chunk here, right, to the stream that's taking the output. We want to pass in that result size. So it's not really the result anymore, right? It's just the size of the thing. And we want to pass in the contents here, but I'm not sure whether we want to add the null terminator or not. I'm going to go with not for now. So here's what I'll say. Let me just throw this out there. Null terminated strings are terrible. I don't like them at all. Because Handmade Hero was built on C without a preprocessor, without any kind of ability to do length-based strings, it kind of has that infection of null terminatedness that comes up from it. At my day job, I never use null terminated strings for anything. And so the reason that I'm equivocating about it here is just because I would normally never store the null terminator because it's dumb and it's just wasteful almost always and harder to compute with rather than having just the size and the contents. But because we sort of have a little bit of C-ness baggage that comes with programming in it, and the fact that you can't define a string literal properly, and if you were started to call the C runtime library calls, you have to use a macro to define a string literal that's correct and all that. It's annoying. You end up doing this kind of stuff all the time. You have to wrap all your strings. It's just I don't know. I think probably the thing is do it right. So I'm just saying I'm not going to store it. And if we have to go rework some code, that'll make that code better. So fine. Forget it. We're just going to do it. So we're going to say that the contents is exactly how much got returned. Okay, that's just what we're going to say. So what I want to do here is I don't know if we have a push copy. We do. Oh, but not really. So we've got kind of exactly what I don't want. We've got push and null terminate. I want the push and don't null terminate. So I want a push copy where I can just pass anything I want, right? And I want to just, copy it in there, no null termination, return it, right? So I want to do a push copy. That's going to give me my contents. The thing that I want to copy is what's in the buffer. I want to copy as much of it as the format string list actually put in there. And I'm going to use whatever the memory system is that came from the stream. So the other thing that I should point out is this is probably its own kind of operation as well, you could imagine. If you look at what this does, this says here's a thing that I want to write into a size destination. Another way to look at that would be I want something that produces the string result. I want you to make a copied one of those. Well, you know what? I'm not going to do that now. Never mind. I'm just going to leave it like this. Okay. So inside push copy, what's the problem here? Push size. Undeclared identifier? What? What did I mess up? Identifier push size. Oh, is push copy a macro? Maybe we already do have a push copy. Oh. Never mind. Got ahead of myself there. So we did have the thing that I wanted. All right. So push copy will take care of all that for us. We're pretty good to go here. I'm going to go ahead and just say, look, let's go ahead and make this handle arbitrary sizes. Fine with that. And we'll just deal with that. Append chunk, we'll have to take that too. There we go. All right. And so now I think we're good to go. I don't know. Yeah, so we should be able to actually test this too. If we run this, oh, you know what? I got to set a breakpoint though. We're never going to see it. We should see our error streams come back now. But in order to do that, we have to prevent it from closing the window. So I'm going to go ahead and run to there. Here it loaded up that giant 8K by 8K thing. So what we can see here is, yeah, everything is, there's no errors, and here's all the info. That's exactly what we wanted. This printout looks busted. I think that's because we never actually stored the information that I wanted us to store. So when we do that append chunk, what I want to do here is I'd like to have the append chunk return the chunk so that if you want to store the chunk information, you can. I could also make the append chunk call be the thing that actually, but I don't want to do that for various reasons. The reason specifically is that since this is a utility function that takes these two, if I had append chunk actually be a macro that took the file in line, all of the chunks would appear to come from inside the outf. I don't want that. I want those to come from whoever called it, right? So I want to set those things here. So there's the file and line number. That information is now preserved. This just needs to return the chunk in question, like so. And off we go. So now when we run this thing, we should get a printout that says where all that stuff came from too, which is good, because again, it's just nice to know. So here's where all of that, if you just wanted to know where it came from. The reason that I wanted that in there for reference purposes in the future, is that without that information, it becomes harder for a HUD system or an on-demand display system like what would be in the game to be able to tell, for example, an artist where a particular problem came from. So, for example, let's say an artist calls a programmer over to their machine and it's like, this PNG isn't working and this is what the game said. Well, if the programmer just sees some like color type is unsupported message, you know, in this case, because I'm the only person who wrote all the code, it's not that big a deal necessarily. But in the grander scheme of things, you have to understand that programmer may have never even heard of the PNG code or has maybe never touched it. Being able, having that program be able to see, oh, here's where that error is coming from, saves them a lot of time and energy trying to figure that out and doing some kind of project-wide search and hoping that the message happened to be unique enough that it's easy to search for and blah, blah, blah. So at that point, it's just a way of making it easy for the person who comes over the artist's machine when something isn't working to know where that error is coming from and how to address it, right? How to start debugging it. So that's it. The PNG stuff should now be compilable into Handmade Hero if we want it to be, and I think we do want it to be. So if I just go in here and do an include handmade.png.cpp, and I should be able to, inside here, also do the same thing. I don't know where the asset system gets included here. Probably should be here. So yeah, and then we need that stream bit. I don't think that's in here anywhere. So yeah. So everywhere we include handmade shared.h, I'm just gonna go ahead and put handmade stream.h in there. Something like this. And so now we should have that code integrated in, and we can call at any time. We can call the PNG reader to load a PNG in, right? And once we load a PNG in, then we can do whatever we want with it and go from there. So what we need to do now is kind of embark on the task of, like I said, the architecture in the game is probably not going to have to change much. What we're going to have to do is make our asset system, and not, I guess not really the asset system, the asset storage format is going to have to kind of be more aware of what's going on. So what we need is a way of expressing the fact that assets can be loaded at runtime and those become the new permanent assets to use in the game. Not sure how to say that in a better way. Currently, the asset storage format, right? Where is that? I forget where we put that. It's like, I thought it was called a HHA or something like this. File formats, that's what it is. So currently what we do is we have this thing that has all of our assets in it, and the assets in this system have never had to understand the concept that they would be overwritten, right? So when you look at like an HHA bitmap, for example, here's the data for that bitmap. We just expect to load that out of the file at a particular location, and we don't really have any sort of awareness of what's going to happen if that got overwritten or something. We don't necessarily even have a way to make more space. We can write new HHA files, I suppose, because we can load multiple HHAs, but like, for example, the asset count here is, you know, I guess we could just append on the end. We couldn't add more types, though. Like, there's just a bunch of issues. I'm going to have to kind of walk through it and see how I want to expand it, but the point is, this is the part that is currently not really set up to accept on-demand asset addition to the system. Everything else, I think, kind of is. Because the code for all the rendering doesn't really care about that at all. So what I think we want to do now is kind of update this stuff in some way as to make sure that we can move forward with that kind of a procedure. And that's going to be the majority of our work. And it's probably not going to be very complicated when it's done. It's just, it requires us to think it through and do a little exploration to figure out what the right way to do that is, right? That's kind of really all we're talking about here. Okay, so at first, I want to look at the Handmade platform system. We have this idea, platform get all files of type begin, platform get all files of type end, right? And this allows us to iterate over files that exist in the system. I don't know what information it gives us, but I suspect we need a little bit more information. I suspect. We'll find out. If we look at the asset system, here somewhere, here we go. So if you look at the asset system, you can see us iterate over all the HHA files. We say get all files of type. We then say here's how many there are, and let's go over them. And when we do an open file for that file in question, we just get back a handle, right? That's so we just iterate over them one by one, and we get them back. Now, the problem with that procedure is that if we now want to expand that, we don't have any way of doing something like only loading files that have changed or something like this, right? So if you imagine we wanted to write this system such that what it does is it waits for the artist to update a PNG, and when the artist updates that PNG, it loads it in. We don't really have any way of doing that currently because we don't even know, for a given PNG, what the date on the file was. So we don't have any way of only checking PNGs that have at least had their date changed since the last time we saw them. And that's not going to work, right? So we need that to work. And we need to expand our platform API to support that. Otherwise, we're never going to know what to load. So in addition to something that loads PNGs, extracts the positions from the sprite sheets, and puts those sprites into our permanent asset storage, we also need to expand the platform API to give us the ability to know when we have to do that. Those are the two, issues that we're facing at the moment. Now we've got about an hour left in the stream, so we should be able to start down one of those paths. I'm just not sure which one it should be. I think let's just start at the head end because we know that part. It's fairly straightforward. So what I think we want to do here is say, let's start by just making something that watches a directory, and when a PNG in that directory changes, we know. And that's it. We're not going to load it or anything else. We're just going to know that it changed. And that, I think, will take a day or two of episodes. It'll take 2 episodes because we need to do 2 different things. 1, we need to have the platform API support that. 2, we need some kind of a permanently stored checksum for the file and date for the file so that we don't recheck files every time we load the game. So to give you some perspective on what I mean by that, we boot up the game the first time, it has to load all the PNG files because it's never seen any of them before, potentially, right? But every time thereafter, you don't want it to load those PNG files anymore. You want it to remember that it had loaded those PNG files and it doesn't need to ever process them again. Otherwise, you end up processing every PNG every time you load the game, which is a massive amount of startup time. I mean, these are 8K by 8K PNGs. Just decompressing them, even if we optimize the code, is going to be a significant amount of time just in terms of doing that 8K by 8K extraction. And it's a nasty serialized process too. So even if we spend a bunch of time optimizing that, it's still just dumb to do it every time, especially when you consider, I mean, maybe when this game ships, there could be hundreds of PNGs in there. Forget it. I mean, that's still going to cause a multi-second, even at a very highly optimized system, it will be many seconds of startup time. Processing those PNGs every time you load the game, not acceptable, right? Definitely don't want that. We want the game to launch instantly, and the only way to do that is to have a cache that says, here are the PNGs I already loaded, here are the dates on them, here are their checksums. Don't load a PNG if its date matches this, because I already processed that one. And if you do see a date mismatch and you load it, do the checksum. If the checksum matches, update your date and don't do anything. If the checksum doesn't match, process the PNG, basically, right? So we want that sort of 2-tiered asset management system that can understand how to make that work. So I think that's fundamentally what we want here. Yeah. So we've got a lot of work to do, and let's just get started. So inside the platform layer, we already have the open files, blah, 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 nonsense, whatever it is, get all files type again. So what we see here when we do this, we've got this sort of way of asking for different types of files. And what I think we want to do there is just go ahead and talk about the different file types. So we've got asset files, we've got save game files, and now we just want one more, or maybe 2 more, which is a PNG and probably a WAV file, because we want to be able to put both PNGs in and sound effects music files in. So I think what we want to do here is say, all right, let's go ahead and get those 2 out. So now we have the ability to switch on those and produce listings of their files. So if all we wanted to do was load all the PNGs, we'd be done. That's all we need to do. But we don't want to do that. We want to have a way of getting information about the files. Now, one of the things that's kind of a little bit weird about this, right, is we've got this sort of like, we've got this like open file, and I think there was like a get next file. How did this work exactly? Yeah, so it's called open next file, right? And we kind of need, so we need like another thing from that that tells us, you know, the information or something. right? Something that's like tell me the file info, you know? And what I don't really know is I don't know, did we ever get a name or anything? It's like, I guess we didn't get anything, really. Like there was no way to get any information. Yeah, I mean, it looks like there's just no way to get any information out of the system at all, which is, again, was fine for what we were doing, not really fine now. So what we want to do here is we want to have some way of yeah, we want to have some way of getting that info. You know, I don't love this system. It seems overwrought to me, and I don't really know that it makes a whole lot of sense. I kind of just want to fix it, and I think we probably should. So if you look at what's happening here, there's iteration for no reason. And I think we deliberated about this. I'm not sure why we decided to go with it the way that it is, but I don't think it's very smart. I think we probably want to do this a little bit differently. I feel like the better way to do it would be like this. Something where we said, okay, here's the file count. Sorry. Here's like the file date. That's, you know, just some 64-bit integer that represents the file date. We don't necessarily have to understand it. So it could just, you know, it could be the date as far as that platform understands the date. You know, it's some platform 64-bit represents the date. Doesn't have to mean anything to the application. So we could have the platform file info there, and then we could have, you know, the name of the file. So something like in here, you know, we'd have, this is the name of the file that you would use to open it, or so that we can parse the name of the file and know what its name is, because that's what we're going to have to go on to figure out what this file should actually be, right? Because, you know, we're going to load something called character hero. If we don't know what the name of the file is in the app, we're not going to know what to do with the data in the file. We're just going to have a bitmap. It's going to be like, what is this bitmap, right? So we kind of have to know that information as well. Yeah. So we're going to have that name, at least the base name. So, you know, we could say this is like without the path, right? In fact, it could just be, it's just the raw, like the name that the artist gave to the name part of the file, right? So, yeah. So there's a couple extra things here I think are worth noting. So if we also consider the fact that these files don't necessarily have all of the information in them that they need, I'm not sure how we want to deal with that part. For example, suppose we have a like one of these files. Just trying to think out loud here. Suppose we take a look at some of these files here, right? Let me think of a good one. Maybe like one of those ground cover. Oh, well, you know what? This could just be sorted, I guess, in the art file. So, you know, let's say we look at these, right? We just got a bunch of little tufts of grass or whatever. We need some way of saying, like, what the different ones are in there or when they should be used or something like that, right? And some of the stuff is rote, like we know that the grid tells us that, but like say this. We don't know how big each of those trees is supposed to be in the world, right? We need like a scale coefficient. We might need to know like a hot spot, like a you know, we might need information. We might need information to tell us like what to do with some of these things, and ancillary information. And so I was trying to think of like how would we handle that? And I guess what I'm thinking in my head is just, well, we could just store that. That could just be set in the game using something, and that's probably fine. So yeah, I think I guess that's not really that big of an issue. I feel like this is a good Krampus. I like this Krampus. So I guess that's all fine. So we'll just say forget about that stuff, and you know, we're off we go. So I'm okay with all of that. So I guess all we really need here is the ability to interpret the name. We need to know what the date is. And then from there, I think we're okay. So what I'd like to do here is say, okay, the platform file info is just going to point to an array of these. So you call this thing and off you go. And then what I'd like to do is say, all right, when we do the begin and end of this, when we do platform open file now, and you pass in a name, I'm sorry, and you pass in a file group, instead of just the file group, now maybe you pass in the file index. So you say, I want to load file 12, you can just load it. So you don't have to do open next file, it's just like platform open file. Like that's it, right? So I feel like that's better. I think that's better. Yeah. All right, I'm happy with that. So that's going to cause us, that's going to mean that we're going to have to kind of upgrade that part of the code a little bit, but that's fine. So off we go. So this code can still work the way that it was working, but now it's got to pass the file index in here, right? And that's fine. And this code now has to behave differently. right? It needs to behave in a different fashion than it did before. So this whole set of things here, the get all files of type begin, this thing is going to iterate, when it iterates over here, it's going to snap a bunch of information. When it ends, it's just going to free this sort of stuff that it's stored, right? And when we do a Win32 open file, it's going to have to look back into the piece of, it's going to have to look back into the data that it put forth there and produce the result that way. So, like, again, this shouldn't be too difficult, but that's just the basic idea. So what you can see here is we just read, and this is probably another thing we're going to have to sort of figure out a little bit here. We're just reading out of a stem. We don't know where we're reading because we assume that we just are always in the directory that has the files that we need. And now that we're loading PNG files and stuff out of potentially a separate art directory or something like that, we may have to become cognizant of what those paths actually are, right? So if you look back at how we've structured the directory, in here, you can see that we've got art, data, and we'd probably have eventually another one here that's like music or sound, you know, stuff like that. And so when we're inside this data directory, I don't know, I mean, we could do it so that the data directory is still the, you know, for lack of a better term, run tree. But usually you want the ability to like delete that and rebuild things from it. So I don't really know that that's the way that we would want it to work. So I'm trying to think here. So I guess we would, you know, I'm just trying to think how we said this. I guess we would just expect the run directory to be here. I'm not sure. So this is kind of what I was thinking. Oops. Something like that, right? I just don't know if that's the right answer or not. So I feel like that's probably the right answer, and then the executable would just go in the root there when you ship the thing. And when it runs, it looks in data for data stuff, art for art stuff, and sound for sound stuff. Seems as good as anything else, I guess. Yeah, so basically, I really am kind of conflicted about that. I don't have a lot to say about it. I guess what I'll do is I'll just do that and we'll see what we think when I'm done. So if I look at the file info structure here, And, you know, I might just say that both of these get a platform pointer. So what we would do is say, all right, we pass in the wildcard stuff for whichever the thing is that you're trying to load. I go in here and I would set, you know, where is, there it is. Is that Win32 Handmade? Is this the right one? Yeah. So for the working directory, it would just be Handmade now. It wouldn't go into the data directory. When you iterate over the files, you'd iterate over them this way, and guess I have one more question there. Yeah, something like that, right? So you'd iterate over them this way, and then you would say, okay, like we iterate over each file, we push all the information that we need to push into one of these platform file infos, for one for each file, and then we go from there. Now, what I would like is I would like a memory arena for this, so, and I think that's probably what I will do. I can't see a lot of reason not to. So we have a Win32 platform file group. I just don't think we actually need that for anything. I don't know even where that is. Oh, it's right here. So here's the Win32 platform file group and the Win32 platform file handle. I think we can just get rid of those. I think. I'm going to put that down here for now. So I think what I want to do instead is say, all right, there's going to be a memory arena. And that memory arena is what we're going to use to store the information here. So I need that thing to persist. So really what I want here, I guess, is a bootstrap arena. Right? Yeah, and I don't really want to have a struct for this, but I think I need to just for this purposes, right? So what I would really do is say, okay, here's my bootstrap push struct. I want to grab one of these things. I don't need any of this. And off we go, I think, right? Yeah, so I think that's it. And that will create one of those. I don't care about any of these things. Well, I guess I kind of do. So I guess we're returning that, and we're saying that this is the like Win32 file group is this thing now, and we don't care about any of this stuff. More specifically, I suppose. So it looks something like that. As I then go forward, I just do the basics here. I've got the Win32 find handle thing. I guess I don't even really need that. Looks like we just kind of go through here. We loop over and do the file count thing. Yeah, I mean, I think what we can do is just do the loop twice, right? So figure out how many of them we have, and then do it again. And we want to make sure we only do the right number of these because the number of files could have changed in between the initial call and the next call, which is kind of annoying, right? But, and I suppose one thing we could do too, I suppose we could actually respect the fact that that happens on platforms, do this a little bit differently. So I suppose what we could do is say, all right, really what's going to happen here is that you get back something more like this. Right, you get back a linked list of file info structures, and this just has the first one. So it tells you how many there are, and it gives you the first one in the list, but you're expected to traverse them yourself. And then when you load one, you say, all right, open a file. The file is this one. So you don't do it by index, you do it by info. That way, if you have something like this in the base of the operating system that's going to create problems for us, it's okay. It's no big deal. We just thread them through and off we go. So I think that's all we really need. And it's good. We don't need this because it's initialized to 0 at the beginning. So then when we come through, each of these can just be a push struct that takes whatever the memory arena was that we have there with 22 file group. Oops. So each time we go through here, we can push on a platform file info. And we can initialize that info structure to be the information that comes back from this particular file handle. So we will know both the date and the file name because both of those pieces of information are in the find data, right? If you look at Win32 find data, you can see that we get, for example, last write time. So that's the last time it was changed. And we also have the size, the high and low. So with those, the access time and the file name, we don't actually care about the size, now I think about it. We should supply that though. Because then you can read the whole file in. So actually, I take it back. I want that though. So I would say let's put that in there. That seems good, right? So what we want to do here is we want to say each of these things should get filled out. And then we just churn through them, and now we can return the correct thing and everybody's happy, right? Okay, so standard singly linked list operation here. First file info is always going to be the info we made, and if there was a first file info previously, it just becomes the next pointer. So that's pretty easy. The file date is this thing right here, last access time. So ft last write time. We don't want the last access time, we want the last write time. So we want the last write time. That's going to be our file date. Again, we don't care. We don't need to understand the file date. We just need to know that if the file date is the same as the last time we saw it, no one's touched the file. So we don't care what that number is. We just need to know that the number is the same when the file hasn't been touched. When we look at the file size, we have a high and a low. So we can say end file size high, end file size low. And what we want to do here is just loft those up to 64 bits and smoosh them together. Something like this. So convert the high size to 64 bits, shift it up by 32 to put it into place there, right? Just make it do everything in 64-bit, and then smush it together. And now we've got the 64-bit file size instead of two 32-bit pieces that we don't care about, right? So that's that first part. Again, these are, I should put these in the struct. They're coming from the struct, so it's actually that. And then we have, so the platform information here is going to be the whole file name, like so, what we will actually need to use to load it. But then here in the base name, what we want to do is get rid of the rest of the stuff that's on that file name. I'm not sure how to do that well, to be honest, but I think we just want to do a push size on it. So I think what we probably should do is write this is going to go away as soon as we call find next file. So we know this is a push copy. So we just put that on there. And this is also going to be a push copy, but the problem is that we don't actually know. Oh, and I should say, I guess I'll do push and null terminate or something. Yeah. And the base name is going to be the same. The problem with this is we don't actually know what part of this to use. So we first need to run a search on it to find what part of the file name actually is like the part that the artist set, minus the extension, minus the path name. So we need to strip off everything after the dot and before the slash. Those have to go away, right? Now I don't know that we have stuff for that yet. We don't. So I'm gonna say let's introduce a new function here that we can use called, parsed file name. Parsed equals parse file name or something like that, right? You know what? Does Win32 doesn't have one of these, does it? Returns a pointer to the address of the string of successful. Seriously? That's some interesting documentation. What I was going to say is we should defer to the platform's own parser if it has one, because it's a platform-specific file name. But I gotta be honest with you, I don't remember what that is, if it is. Oh boy, and this is not. There's a lot of stuff in here. So they do have a split path, but that's in the C runtime library, I think. Yeah. This is essentially what we want, but we want an operating system specific version of it. We don't really want to be calling yeah, here we go. Pointer to an alternative string of length max path that contains the path and file name. When this function returns successfully, the string contains only the file name with the path removed. So that's good, but doesn't strip the extension, unfortunately. This is a mind-numbing array of files, of APIs. That's not what we want. It's annoying. Maybe I'll just write it myself. I wanted to try and defer to Windows on this, but they're making it really difficult for me to do so. These are URLs, which doesn't help me at all. So, I don't know. I would like to defer to Windows to have it remove the parts that we don't want. Because if you think about it, operating systems differ in how they handle path names, right? So in in something like Unix, a path name of the form w:\foo is just the name of a file. But w:\foo in DOS is actually the name of a drive plus the name of a file. And so typically speaking, you don't usually want your file name parsing, the file name parsing part of your code wants to be in the platform specific part of the code. And where possible, you'd like to defer to the operating system to do it for you, because if it can do it for you, it's going to know better than you what the legal prefix path names are. For example, on Windows, there's UNC path names and all these other nonsense things, and we don't really want to be in the business of parsing those things out, right? That said, because we know this is going to give us back relative paths, in theory, we could just skip the part that we know that we added ourselves and then truncate the extension, which we know that we added ourselves as well. And so in some sense, it's probably pretty easy for us to do. So given the fact that I just don't have much confidence that I'm going to find a Windows call to do it, I guess I'm just going to do it myself. So what we want to do here is say, okay, in this thing here, I want to be able to find the last slash, and I want to be able to find the period, right? So I want to do something like this. I want to say find data C file name is where the base name begins by default. And then I want to say that, something like this. That's where it ends, right? And then what I want to do is I want to encroach on the file name as necessary. So then I'm going to do a push and null terminate with a length on here, or I could do a push. I guess we don't have a push. I guess we don't have a push copy that necessarily does this. So I'm not sure exactly how I want to do this. It'd have to be something like this. We'd have to null terminate it ourselves. Again, this is why I say null termination is terrible. You really don't ever want it if you can get away without it. So anyway, starting from the base name begin and running till the null terminator, we will scan through. If in our process of scanning we see, well, I'm going to write it like that. If we see a slash, of either kind, let's say, then what we're going to do is say that the base name begin equals scan plus 1. So the next character will now be considered the start of the base name. And if we see a period, then we will assume that that is where the name ends. And then when we're done, we can now push the copy on. We now know the size, or the base name size equals base name end minus base name begin. We now know that we can push a copy on there. like so. Right, and all we need to do here is we need this to be one larger. Now, you may ask, how can I make it one larger than the size? Well, we know that the base name end was either the last period or it was the null terminator. So I can always copy the null terminator since this has to be null terminated. So I'm not in danger of over copying there. I don't think, even if I was, you don't have to really care because one other handy bit that we know, of course you can't find it. There's a bunch of other garbage after it. So copying one after it, even if we did exceed the path for some reason, which we won't, would just copy the first character as the alternate file name and then immediately overwrite it with a 0. So again, all's well that ends well. So this will produce the information that we want, barring bugs that I put in there. And then when we are done, we just need a way of freeing it. We don't need this find close stuff anymore. All we really need to do now is we need to delete the memory. So I think that is in here already as clear. That frees everything, and then we're done. So we should be able to do that, wipe out all of the memory we used, and then we're done. The only thing that won't work now is Win3Do open file is going to try to look for stuff that it can't find. And so that's a problem. So what we want to do here instead is we want to get rid of this entirely, right? And when we do the Win3Do open file, do we have a close file though? I guess we never close files, so we're going to have to add that because we never currently close any files, and now we would need to do that. So we will have to add a close file call because I guess when I think about it, the only time we ever opened files for, we held them open for the entire game. But we're not going to do that anymore. So when we do a Win3Do open file, it allocates some memory for the handle, it looks like. I'm not sure why it does that. Why are we doing that? I kind of feel like that's really dumb. I just don't know why we were doing that. Why were we allocating memory there? There's no need whatsoever for allocating memory there. That's a real mystery. I do not know, fundamentally speaking, why we were doing that. That doesn't make any sense. It is not necessary. There was no reason to allocate memory there. We just felt like calling virtual alloc for no reason, and that's I don't know why that happened. That just seems real dumb. Because when we have this platform file handle, like when we call platform open file here and we return the platform file handle, we don't need to allocate one of these for any reason because there's nothing in it, right? I mean, it doesn't need to store anything. I don't understand that. I don't know what the point of that is. Maybe I'm just not remembering something important or something, but I feel like this should just be this. Because we can just make this as big as we want. Like, we can make this a bunch of extra room. I'm sorry, not that. Here. We can just make this a bunch of extra room. Yeah, that just doesn't make any sense to me. But, oh well. I don't know what I was thinking. So what we can say here is, look, just put it in here. And that should just be fine. So here's the file handle. And off we go. So this is using wide characters as well. So I guess we have to kind of deal with that a little bit. I forgot about that side of things. So let's, yeah, I'll have to do a little bit of work there. So we'll deal with that one second. But point being, we get a file name here. That's just going to be the platform pointer. So that's going to be the platform pointer that I snuggled in here, right, was that file name. So push and null terminate isn't quite going to work because these are wide file names. So that's going to have to be sort of something a little bit sexier there. And this will have to be something a little bit sexier here as well, right? These will have to be things that operate on Windows is fantastic and oh so helpful. UTF-16, the world's worst encoding for Unicode characters. So it's all right. Most of this stuff will just work if you just use wide characters for it. So that's all fine. But the problem is we need some, yeah, like this string length ain't gonna cut it, right? So we need to actually look for the end of the string as well. Which actually is pretty easy. So we can just do that like this. Right? So either we found the end or we didn't, and if we didn't, we just, you know, find it now. So I think we're okay with most of this stuff then, and what I could say as well is scan is now the end too. So I think all this stuff now just kind of works. The problem is this part right here. So we now have the info platform bit here. This can just be a push copy. It can push on the find data C file name. What we do is we take the file name. We know how long it is now. We know it's scan minus the beginning, right? So we know that's how much there is, and we just need to push that on. And I think that just works because it's pointing at the null terminator. So I don't know if, well, I guess we need to copy one past that. So it's that. So we still can do it even with wide characters. That puts the wide character string in there. We want to pass the non-wide character version to the game because the game just deals with ASCII. So we want to pass it something that's been converted. That is something Windows can do for us. Where's my search? There we go. Win32 wide character to ASCII. Let's see here. Where is the actual... I just want the MSDN version, please. This is not even remotely what I was asking for. You know, I can't stand MSDN anymore. It used to be good. There's a Windows API call that does exactly this. There it is. Thank you. God. This is the one that I actually wanted. Wait, what is it talking about? Using multi-byte to wide char... Oh, I don't want multi-byte to wide char. I want the opposite. Thank you. Using wide char to multi-byte function correctly can compromise the security... Okay, yes, I know that. Thank you. This can take counts of each, though, right? So as long as you pass the right counts, you're fine. Am I wrong about that? Not sure where the actual problem comes in. But this is what we actually want, right? So what we want to do is call this here to get the, this one gives us the platform non-specific name. To get the platform specific name, we need to call this dude right here. So we need, in this case, we need to figure out, how to package this up. We don't know how, if somebody used some kind of a Unicode file name here that was encoded in UTF-16, who knows why we won't, but if someone did in the future, we need to have enough space to store the entire base name, right? So we know that the base name size is this. We then need to say, well, we know that we've got the base name size, but it might amplify, right? So we need to leave enough space that you could take the 16-bit and turn them into 8-bit ones. So I'm just going to take and assume that it might take up to 32 bits worth of the 8-bit space to encode a 16-bit when it actually blows it out. For now, we don't really care if it gets truncated, because if people are using it like that, I could care less what happens to them. So really all we want to do is make sure that when that thing converts, if it was trying to convert a legitimate UTF-16 name for some reason, that it can do so. And so we'll just go ahead and make sure that that happens in here. So with wide char to multi-byte, what we need to do is we need to pass the code page. The code page in this case is going to be UTF-8, right? That's the one we're going to, if that makes sense. So CP UTF-8 is what we want to convert to. The flags, I don't think I care. Yeah. The wide character string is the stuff we got back, and the number of characters in it, right, is going to be that difference. Like so. Then what we have to do is give it the output pointer, which is this thing. And then we have to do this. Windows' use of UTF-16 is such a pain in the butt. All of this code is nonsense. It's not necessary. If they just used UTF-8, which of course they weren't smart enough to wait for and or invent. I think the Plan 9 guys did it. And then they put it into X Windows and Linux and stuff like this, but Windows had gone like, nah, UTF-16, great idea. So anyway, we have all the stuff there. We just need whatever the default char parameters are here. I don't know what those are. If we cannot, we don't care about that, so we can just set those to 0 and 0. Can we? We don't have to pass. Do we have to pass this in? Yeah. So we can just pass a 0 because it's UTF-8, which means it should be able to represent everything in the input. There shouldn't be such thing as an unrepresentable input. When this thing returns, it's the number of the bytes written. Does it include the null terminator? Does not null terminate an output string if the input length is explicitly specified without Okay. So what we want to do here is we want to say this thing that we get back, right? We want to say we're going to give you that much space. We're going to reserve the right to null terminate this thing. So when you return the value to us, we're going to do it ourselves. Right? So I think that's everything we need to do to first give the application a ANSI compatible, well, UTF-8 name that it can read. And also preserve the wide character version, which is what Windows needs to actually load the file. So we preserve both of those two things. And then when we go to load the file in here, we will actually do that file load. Like so. So, okay, so when we go to open the file here, let me just make sure all this stuff is right. We want to get the file name out of the platform. It's going to be a wide character file name, which is good for us. We open it for reading. We see whether or not we got errors in there so that the platform can know. We don't need any of this stuff now. But probably what we could do, well, I guess no, they don't really know that was anything we need to do. I think we're fine. So the only thing that we're missing now is we do need a Win32 close file. Not sure why that's called platform file error. I think that was just a typo there, probably because we hadn't finished that yet. Anyway, what we need here is a platform file close, and the platform file close call would need to be able to take the Win32 handle from here and close it. So what we want to do is say, all right, if whatever the handle is that comes in, and let's go to the platform section and actually make this because we don't have one at the moment. So if we have in here a way to do a platform close file, which now we're going to need, the platform close file is probably just this, right? So you pass in the file handle that you're talking about. We then want you to close it. So what we're going to do here is say, all right, here's the handle. It is exactly, oops, that won't work. Here we go. So we want to sort of look at that piece of data as if it were a handle and write it in there, right? So that's what we're doing here. We want to get it out the same way. So we just want to say that part we want to interpret as a handle. So then we do. If that handle is not equal to invalid handle value, then we will close it. If it is an invalid handle value, then we don't have to close it because it wasn't ever open, effectively. When we do our read, we need to do the same thing here. So we don't actually need to do any of this nonsense here. What we actually want to do is, and let me see if there's anything. Save truncate read file. Yeah, I don't think we care about any of that. So what we want to do here is say, okay, we've got a Win32 handle that comes off of the source platform piece there. We don't want that. Yeah, and I think that's it. Is there anything I'm missing there? Yeah, so there's now a little bit of a difference here, which is the platform file info is going to come from the file group like so. So we just move through these, and on each one of these, we, and you know what, we can also, we're going to need that file index as well. So in here, we can also assert that the file index is less than the file group file count. So in here, what we're just going to say is, okay, you know, we're going through the files. We're looking at each one of them. When we get in here, that's the one we're going to want to load, right? So again, that loop has not really had to change any, which is good. I didn't want it to have to. File time, I don't know if there's an easy way to cast this. We may have to sort of reassemble it. If we look up the file time, yeah, fine. Why do I even bother? So the file time structure has the low and high in there. So we can do the same thing here, just assemble the 64-bit version of that. Right, and we've got low date time and high date time. Okay. What else we got? Yeah. Yep. So when we do a push size on this thing, this part is now no longer relevant there. That's Caristar. This doesn't support UMMs, apparently. So we're going to have to go small on that. All right. So what else do we have here? Win32 open file. That just needs to be a cast. Win32 handle is extracted directly there. And looks like mostly we're good. I think that's supposed to be close file. All right. Okay. So yeah, now we got to go look at all that stuff because we made a ton of assumptions in there, and we're going to have to actually figure out what's going on. So let's just, this is exactly where we want to be. Let's step through all of this stuff and see, get this stuff going correctly. All right, because it shouldn't take too long to debug, I don't think. All right. So we do a bootstrap push struct. No, I guess that's fine. So we do a bootstrap push struct. Let's make sure that that's all right. So here's our memory. It'll allocate a block to store stuff. We could probably make the block smaller than that, but we don't really care at the moment. So we're going to look for HHA files. So there's the wildcard. We initiate a find on that. And we say, okay, first we got a file. We allocate a file info for it. I'm going to bring that up here so we can watch it get filled out. There are no other files in it yet, so that's not going to, be anything. We create a date. We create a size. I think that's right. It looks about right for the name of the HHA file, that big intro art pack one. Then we get the base name begin and the base name end, like so. And then we scan it. In this case, it just says intro art. Okay, so I will probably have to do this slightly differently. So it looks like when we do this find, I had forgotten how this worked. When we do this find, the file stem doesn't get included. So this load will not work. This one here, right? That actually needs to kind of have it, when you actually open it here, it needs to actually be relative to, where is it? Here. This actually needs to be relative to the path that it asked for. So that's not going to work. So we got to fix that. But let's see how the rest of this stuff worked. So in here, let's see. So we did get the correct information there. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So we say that we need a big old buffer just to make sure that there's room for it. We push that in there. We then say, hey, Windows, can you convert that for us? It did. So there it is. We also then push the copy of that onto here. I don't know if that actually pushed the copy on properly or not. We don't know. So we go through and we do this whole little dance, and then we finish up. So then at that point, we effectively have so we produced all of that correctly, looks like. And then when we return, this thing pretty much just works. The problem, I suspect, is just right here. Because now we come in here and the file name is... oh, and looks like we didn't use the whole size of that thing. Yeah, I got to fix that as well. But this is not right because it doesn't have the path prefix on it. So we kind of need to do... This is a more involved process than just that. If that makes sense. So looking through here, what we need to do is, first of all, yeah, like this part, I don't know why that part didn't get the whole thing. Because it should have. Like, I don't know why it didn't include the extension. You know what I'm saying there? That seems a bit weird. So, yeah, the good news is this doesn't have to happen, basically. Like, this is not relevant. The bad news is that the stem has to be added on. So we basically need something that's like this. Right, so we need to specify that the data comes in here. It's just, yeah, it's really annoying, but that's just how it's going to have to be, right? So basically we need to we need to push that on to the beginning of the access pattern in order for this thing to work. Because, yeah, that's just how that's going to go. So I could just do that, really. But so once you look at what's going to happen here, then what we need to do when we actually do the push copy here is we need to do a push copy of first the actual C file name part, and then we also need the stem, right? So in here we need a thing that says however big the stem is, and then we need to push the other part on. Now the weird part about this is that the extension was getting stripped off of our platform copied version, and I don't know why, because it should have worked. Yes, I know why. So this is a byte length. This actually needs to be like that, right? So we need to push on something that is the size, whatever that C file name is, that thing's array size needs to be taken into account. I mean, the other way we could do it is like this. Right? Because this have to be wide chars. What we really want to do is just be able to sort of append the stem. This is why I say, again, null terminator is just a pain in the butt. You want all these things to just have their lengths included with them. It makes all of this code so much more easy to write and less error prone. But if wishes were horses, we'd all be at the airport. So anyway, what we need to do is actually write that part ourselves, I guess, which is fine. So we need to include the stem size here. And this can't really be a push copy, right? We're going to have to do it ourselves. So forget the push copy. Think of it this way. That's the size of the scan part. That's the size of the final name part. So we can put that here. We can also actually just include the +1 in that guy. And then we need the stem size. Once we have that, we can do 2 copies to put them in there. We don't have a copy array? Seriously? Yeah, I guess we don't. Is that really true? That's really true. All right. Well, no time like the present. So a copy array is just a count, a source, and a dest. And then that just calls copy with the count parameter times the size of the source, right? And you notice I parenthesize those just in case, I guess I can do it here as well, just in case there's any kind of interceding piece of information there. So, like, we don't, if this was a complex expression, we wouldn't want it to accidentally only star part of it or something like that. So I just over parenthesize that just to make sure. Anyway, so I want to do these 2 copies. So what I would like to do in this case is we push the array on here for the file name size, the stem size, and we got the file, the C file name is actually now just a thing we're copying from. So I want to copy the stem into the info platform. And then I want to copy the file name into the platform plus the stem size. Right. So I want to copy the stem size here. I want to copy the C file name size here. And that should do it for us. So the only thing we actually need in this case is we need a way to know how big the stem actually is. And I don't know that there is a function for that in Windows. There probably is one in the C runtime library, but not in Windows, I don't think. And we could make a thing here that actually just did it automatically because we know, but you know, I'm not going to start down that road at the moment. And so all I want to do here is say, all right, there's a stem size. Count it. That's it. Don't ask me why there are 2 equals there. There shouldn't be. And off we go. All right, so let's see if we've done any better now. So we're going to jump in here. Let's see how big the stem size is and what the stem is. It is 5 characters long, and it says it's 5 characters long. That's good. We've got our base name now. Intro art.hha. We look at the size. 9, that's correct because we're stripping off that part. 1, 2, 3, 4, 5, 6, yeah, we know that's right. So now we're going to push on some storage, do the multi-byte char thing. We kind of know that that part's already correct and we haven't touched it, right? So now the question is, can we produce this thing right? First we got to see what the C file name size is. It's 14 characters. That's probably correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, no, that doesn't have the extension on it though. So why doesn't that have the extension on it? Oh, right, because you haven't put the never mind. It has the extension on it. We haven't put the other part on it. Okay, yeah, that's fine. So then we allocate 14 plus 5, right? So we've got a 19 character buffer, and it's WCART, so it's wide, so it's actually twice that size in bytes. We copy the stem on. So there's that part. Then we copy the file name on. And then we're done, I think, right? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, and 19 for the null terminator. So it's exactly the right size as well. So great. Okay. So now we have, in theory, produced the correct thing so that now when we open files, we have that ability. Let's take a look at what the file name is. That's the correct file name now. So no errors is 1. That's good. And off we go. So hopefully now we can, figure out how to do the rest of this stuff. Looks like we have a bug in there, though. I'm not sure. Oh, was that the bug about the weird, like if you take too long to start up thing? Yeah, we should probably fix that. Oh, no, that's not what that was. That is just the, that was just that we're generating too big of a world, I think. Is that what that was? For a single sim region? Maybe not. I don't know what that was. To look up. What was that? Not sure what that was. I don't like that though. Looks like it created more stuff than we have, more elements than we have. But anyway, it looks like that's loading correctly now. So that part of the system is now ready to do dynamic loading, I think. So that's good. All right. All right, let me see about Q&A stuff here. There we go. Where will the assets be stored when they're not reloaded from the PNGs and waves? In our HHA files. So PVOP, I thought asset system allocates based on headers read from asset files. That means you can replace resources with dynamic reload, but not add new ones. And you can't add tags, or I'm missing something. So did you not hear me specifically at the beginning load up that actual file and say exactly that we would have to modify it so that we can put different tags in there? Or maybe you forgot that I said that? Not sure. How we handle the switch between HSA and loose asset files? We are not switching to loose asset files. They will all be in an HHA. It's just we will pack the HHA as files are updated. For future reference, since you might be looking at it in the next few episodes, get file attributes EX with a get file X info standard flag comes out the fastest of all the ways to get the file size from the Win32 API. But we don't care about getting the file size from the Win32 API. We already get that when we do find first file, and we have to do find first file because we don't know what the files are, right? So just getting the file size doesn't really help us. Will you do my comp sci homework for me? No. Sorry, I meant file mod time. Yeah, same thing. So basically, getting the file modification time doesn't really help us because the only thing that getting the file modification time does is allow us to check for a file that we already know is in the drive. But we don't know what files are on the drive, so we're always going to have to run the find first, find next anyway, right? And if we have to run the find first, find next anyway, we might as well just get the size out of that because it's already there, right? We don't have to make another call. If we already said these are the only files we'll ever look at, then we could just look at them that way. But Do you intend to allow hot reload of things like metadata? You sort of mentioned it, but it didn't follow from what you're thinking. Well, I don't think those will be stored in external files. I think those will just get written into the HHA, I guess. Or we'll put them in the C code. I don't know how we'll do it. I'm not sure about that part. Which language is better in the game industry? C, C++, C Sharp? Well, it's really not a question of better. In terms of usage, it's basically C++ is the language that is used. Different places use more or less of it. So some places use it like I use it, where it's kind of just C, but you still compile in C++ and usually use some of it. Other places go nuts and use tons of C++ features. That's pretty much it, period. I mean, that's what the whole game industry is built on. Once you start looking at scripting code, so stuff that's above the engine layer, then Unity games use C Sharp, and Unreal games use Blueprint as a higher level. Arguably, maybe more artist friendly. Blueprint is probably more artist friendly. C Sharp is not that friendly by comparison, I guess. In my system, I have a thing that you can register a file name, and when it changes, a callback function is invoked. Then for every file I have to load, I add an entry in that table. What do you think of add callbacks? I don't really like callbacks, so I much prefer either messages that go into a queue and then you can read those at your leisure, or just the app pulls for them. I mean, basically, I prefer queue-based behavior. I don't like callbacks. I really don't like inverted control flow. I think it just generally creates problems. If the artist changes the art, then the hotspot might change, so it could be tricky. Yeah, I mean, it could, but it's one of those things where, like, we can just put something in the game that says adjust hotspot, and then it resaves it to the HHA, so I'm not sure it's a really big deal. If that makes sense? Like, I'm not sure it's really that big of a problem. How often people in chat suggest you rewrite in Rust? I don't know, because I don't read the chat, except when people ask questions. I don't think people have ever really asked me a question to rewrite the thing in Rust. I guess I would say anyone who thinks that Rust is like a significant improvement over C++ probably isn't thinking that hard about it, because it's not. Like, it's probably better than C++, but it's not enough better that you would ever rewrite something, right? I think that's one of the things that people don't really seem to understand, is that most programming languages nowadays are just not very good. So when you say, like, do you want to rewrite something in this other language? The answer is, like, always no. The only time that makes sense is if you wrote something in a high-level language and you need to move it to a lower-level one, right? Like, if you wrote your whole thing in PHP and it's just dog slow, then rewriting it in C makes a lot of sense, because that's the only way you're ever going to fix it. Whereas if you wrote your whole thing in C and someone says we should write this in Python, the answer is just no. I mean, that's never going to be an improvement. So these other languages aren't enough better. Someday we'll probably have languages that are enough better, and then something like rewrite in Rust makes sense, because, where Rust is some other language, rewrite it. Why don't you write this in foobar? And foobar actually is a great language that's super powerful and awesome, then yeah, it would make sense to rewrite it. Right now, it's just like, yeah, it's like putting different kinds of lipstick on the pig and asking you, what you think of it. It's like, it's just, they're not very good. I/O completion ports versus asset loading thread. We don't really have much need for I/O completion ports because we don't hit the we don't hit the kind of outstanding I/O kind of boundaries that would make that useful. You know, I/O completion ports have a lot of problems. So I/O completion ports is a very well designed API if the only thing you're using is I/O completion ports. As soon as you have to do other things, I/O completion ports sort of start to fall apart, right? So I/O completion ports don't help you if you are trying to make a game that has a bunch of other things that want to be on the same thread as the I/O completion ports. They just don't work. And the reason for that, I think, is that Microsoft, fundamentally speaking, you know, they had like 6 dudes who came from, you know, Digital Equipment Corporation who knew how to make a good API, and they made the base NT thing, and they made the I/O completion ports. Then they got, you know, hundreds more people working on the operating system who either came from the old Windows side of things or were newly came on, and they didn't understand I/O completion ports, right? So as a result, most things don't work with I/O completion ports. So you can't really use it the way you would like. Ideally, you would have everything in Windows come through an I/O completion port, and then you would use it for everything. But of course, they didn't do that. Little off topic, there's been a lot of talk about the deprecation of OpenGL and using a lower-level API to talk to GPU. My question is, does NVIDIA's CUDA satisfy this lower-level API requirement for games? So, you know, I haven't really written anything in CUDA, so I can't speak to that directly. My guess is probably not. I mean, CUDA's goal is not really to be that kind of API. It's a general purpose computing API. Originally, it wasn't even really set up to hit things like a 60 frames a second hard budget or things like that. So by now, it probably could be used for that because they have been pushing things like real-time ray tracers and stuff on there, so they would have had to address all those problems. So I would guess by now it could be used as the API. I don't know that it's necessarily a good one because I have not spent much time with it. Right? How do we... So here's a question that I haven't had to answer in a long time. How do you ban people in Hex Chat? Anyone know? You know, Miblo could probably tell me. Is Miblo out there? He seems to know those sorts of things. I don't tend to know them. Yeah, but I don't know if that actually works. Does it? No, maybe it does. I mean, I have no idea. Forgive me for I did not watch the entire episode, but instead of iterating over the entire directory, could you not use functions like read directory changes W and find first change notification W, or will the number of files be so small and this is for debug only and not worth it? So it's actually a little bit more complicated than that, unfortunately. The answer is it depends on how controlled the environment is that you're planning on having this work in. So the way that we wrote it, it'll always work, if that makes sense. Like, there's no configuration that will fail on, to the best of my knowledge. So like, you know, if Windows is running at all, this will detect changes and find new files. If you use read directory changes W and find first change notification W, my recollection is that only certain ways of running the file system actually will produce correct results. And I don't remember what all those circumstances are. So, for example, I think it only works on some file systems. So I think like NTFS maybe is like the only one, or so, you know, there's something like this. I think it doesn't work when network shares correctly, maybe sometimes, things like this. I don't remember what they all are. So don't take any either. I know those things I said as being true. I'm just giving examples of things that could be true. I don't know that really always gives you the information you need. Also, I don't know what the update frequency is of that either. So if you don't have, 5,000 files, which we don't, and I don't think we will, then I believe it just generally behooves you to do it manually, because you're at less of the mercy of the operating system and its own particular opinions, if that makes sense. So, in fact, it may say, so it doesn't really talk about it too much here. I mean, they sort of have a list of like, hey, if you use these things, it's supported. NTFS isn't even one of them. So I don't know what that means, because I'm pretty sure it does work on NTFS, or at least in certain circumstances I thought it did. But I don't know. So there's that. Don't suppose there's a chin on this, is there? Yeah. So I really just,
sorry I don't have better information about this.
I can just tell you from experience that it's not as reliable as one would want. And maybe it's the case that nowadays everything is going to be running on something that will generally work, and so it would be fine, but I can't promise you that that's true. Uh, it would be nice to have a Raymond Chen on that, to be honest. Would it be a good idea to abstract render push buffer? That way you can use Vulkan command buffers or whatever Metal has with less memory copying. I mean, possibly. Uh, Probably not. Because we really don't. I think probably what we'll end up doing is something that produces a buffer that can be used with either of those anyway, for the most part. Because once we don't have to switch textures per quad, then it's just kind of one dispatch anyway. Will your code have to be different when coding for different video cards, AMD versus NVIDIA? So possibly there might be special purpose code for either of those if we find we need that for performance purposes. Otherwise, not really. Looks like we're all done. All right. Oh, Valbus, why do sometimes MSDN functions require buffers to be aligned? I have no idea. So my assumption would be that they thought they were going to get performance increases, or even potentially did get slight performance increases back at a time when that mattered to them more. You know, nowadays their operating system is so dog slow at everything that, like, there's no, I mean, forget it, right? Like, the chance that the alignment of a buffer you pass to the Win32 API is going to make any difference ever is like zero. But, you know, you have to remember the fact that as absolutely as abhorrent as the performance of Windows 10 is today, you know, Windows 3.1 or whatever, they were trying real hard to get everything to run as fast as they could. And there was a lot of work spent optimizing things and getting them to run at all, because the hardware was pretty primitive back then. And you had to do a lot of stuff just to make a multi-windowed operating system run at any kind of reasonable rate. So, you know, there's sort of an overhang of some of that, and so, you know, some of it might be that. I mean, looking at it today and also knowing that Intel chips don't care that much about alignment anymore, you have to understand that, like, priorities change, and so the fact that it looks laughable today does not mean that it wasn't perhaps a reasonable thing at the time. You know, who knows? So, all right. All right, thanks everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always go to handmadehero.org and pre-order the game. It comes with the source code so you can follow along. I will be back here next week, and in theory, the tweet bot is working correctly. Also, the watch, this thing should, in theory, be working correctly as well. Of course, it's got the stupid Twitch advertisements in it. If you sign up for Twitch Prime, it won't have advertisements on it, I guess. I'm not sure if there's any other way to get around that. But the watch window, the watch button also has the schedule on it when the stream isn't live, so you can always go there and take a look to see when our upcoming streams are going to be, and I try to keep that schedule pretty updated now. So it should always be up to date with when the next live stream will be, along with a countdown, so in case you don't know what Pacific Daylight Time is because you don't live anywhere near the west coast of the US, you can just look at the countdown timer and know it's going to be 13 hours from now, or 7 days and 13 hours from now, or anything else like that, which should be pretty easy for people to check. So that's about it. Next week, we will start the process of trying to move PNG files in through some kind of a runtime pipeline that goes into the HHA files so they can be used. Because now we have the ability to iterate over them and do checksumming testing if they've changed, that sort of stuff. So we now have to put that part in place, now that the platform layer supports it. So we'll go ahead and do that. That'll take a couple days for sure, so that'll be next weekend's job and probably the weekend after that. And then hopefully at that point we'll have something that we can do real-time art integration with. We can hand that off to Anna to give us art assets for the game. So that'll be good. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.